So this example, I noticed that the 9, 3, and 24 all share a common factor. And I also see that the 4, 2, and 14 also share a common factor. So what I'm going to do first is I'm going to simplify this into lowest terms, just because it might be easier to work with lowest term numbers. I don't see any common multiples right away, so it might be easier to reduce the terms before I scale them up to be able to match coefficients. So for 1, I'm going to simplify this to 3x plus y is equal to 8. And for 2, I'm going to make this into 2x minus y minus 7 equals 0. So I'm going to divide everything by 2. Now in doing so, now I can match up my y coefficients. I have a plus y and minus y. So I'm going to combine those together. So I end up with 2x minus y minus 7 equals 0. Add those together. So adding those together, I'm going to end up with 5x. The y's cancel out. Minus 7 equals 8. And now I can solve this. I'm going to add 7 to both sides. Divide both sides by 5. I get x minus 3. Okay, so then once I solve for x minus 3, I'm going to plug it into equation 2. 2 times 3 minus y minus 7 equals 0. And so I end up with 6 minus 7. And I'm going to add y to both sides, so I get plus y on this side. So then y is equal to negative 1. Okay, so there's my solution. At x equals 3, y equals negative 1. For example 5, it says, which of the following systems is a coordinate negative 1, 5 a solution? Well, if it is a solution to this system, it must be on both lines, and it must be the coincident point on both lines, so it must fit both of these equations. So what I'm going to do for this is I'm just going to test the point. So I'm just going to plug in negative 1 for x, 5 for y, and check to see that equals negative 6. In this case, that works. Now, that doesn't mean that's a solution. All it means is it is a point on equation 1. I also need to test it in equation 2. So I end up with 3 times negative 1. 2 times y is 5 is 10. And that's equal to 10. Well, this is not a point on the equation 2. Although it works for equation 1, it means it's some point on equation 1. It doesn't work for equation 2. This cannot be the solution to this system. So I'll do the same thing for b. I'm going to plug in y is 5, x is negative 1. Well, x is negative 1. Negative 3 times negative 1 gives me positive 3. Plus 2, check. That coordinate is on equation 1. And I do the same thing for equation 2. Y is equal to 5. Negative 0.5 times negative 1, that's going to be negative, negative, or positive 0.5 plus 4.5. Check. That coordinate is on both equations, which means that it is the intersecting point of both lines. So this is a solution. So B is a solution to that. Sorry, negative 1, positive 5 is a solution to this system. We do the same thing with the last one. So negative 1 times 3 is negative 3 plus 8 is equal to y, which is 5. Okay, that's checked, so it means it's on equation 1. I'll do the same thing with negative 1 and 5 into second equation. So negative 9 times negative 1, that gives me positive 9 minus 2 times 5. That's 10 plus 1 is equal to 0. Here I get 9 minus 10 plus 1. That becomes positive 10 minus 10 is equal to 0. Check. So C must be a solution sorry, the -1, +5 is a solution to this system in C.